All right. Thanks you guys for joining this meetup, WebHack number 43. It's been exactly 1 year since our last online event. So thank you all you guys for picking us up during the last year. We couldn't go so far without your support. So before we start, I would like to introduce a little bit about WebHack. So we are Tokyo-based monthly tech meetup. Before we held a monthly event in different companies, so most of you guys might have attend our offline event. So we hang out and share knowledge like those pictures with food and beer before. But unfortunately, due to the pandemic, we couldn't make online event anymore. But no worries, we didn't stop knowledge sharing during the pandemic. So we keep hosting online events like this. We record all our online event and put the material on the YouTube. So you can search for WebHack Meetup in YouTube and subscribe our channel to get the latest content of our meetup. Given the circumstance is this bad, but we are still growing. So now we have 1,300 more members, and we have 1,800 attendees, and it's still growing. So thank you all our speakers and all our attendees. So if you are interested in give a talk in WebHack, please fill up the form in the link here. So we will reach you up later. So about today's event, we will have a collaborative notes in this WebHack HackMD. So please check out the link. We will share the link in the chat later. Okay, and then finally, if after the event, please help us finish the survey so that we can make our event better. So now let me pass the microphone to today's moderator, Ayana. So Ayana.
Yes, hi. Thank you very much. Good evening, this is Ayana from Rakuten. Let me share my screen. Thank you very much for having us here today. We are very happy to have a chance to talk about our technology that we don't often disclose. We are one of the biggest e-commerce company in Japan and have been integrating infrastructure globally. Tonight, we will share our experience on the large-scale cloud platform. In this event, you can see how Rakuten developers may merge a big number of clusters and components to orchestrate it and scale it. You will also learn how our big data is managed as a good use case of utilizing Kafka and Hadoop for large-scale services. We have 3 speakers today. Let me introduce them. The first speaker is Mitch. Hi, he will talk about Rakuten platform overview.
Hello.
Hi, thank you. The second speaker is Harry. Hi.
Hello.
He will talk about uncrowding container challenges. The third speaker is Daniel.
Hello.
Hi. He will talk about Kafka and Hadoop in Rakuten. And yeah, here you can see the timetable. After their presentations, we will have a Q&A session. While you're listening to our presentations, please input your comment or question in Slido. I will send the link later. Yeah, you can input, this kind of screen, you can input your question like this. We hope you will enjoy our talk and we can have a nice discussion based on your questions later. Okay, then let's move on to the first presentation by Mitch. Yeah, Mitch is Vice Senior Manager of OneCloud Project Office. His talk is about Rakuten platform overview. Please take it away.
Perfect. Thank you very much, Jana, for introducing me. So hello, I'm Mitchell. I probably have the most boring title of all of us. I'm a manager, but I'm actually also part of the architecture and design I've done for this system. I would like to share you a bit of like the experience we've had in actually figuring out what is the problem we're dealing with and what kind of solutions do we have in play. So with that started, with that out of the way, let me give a quick introduction. What is actually Rakuten for the people who might not even know what we are or what we stand for? So Rakuten is a big group of many different companies and different brands that you can imagine that we, from the infrastructure side of things, have to make sure that all these different services, they just work, they're accessible. So it's not something small, it's a big job for us to try to make this all runnable, right? And so as you can see, this is one of the marketing materials that we have, but if you look in the middle, what everything is being driven by, of course, the brand is very important, but you see the communications, membership, and data. So data is very important for the big data department, et cetera. For example, membership, ecosystem services. This is what drives Rakuten Group, and this is actually what makes things possible. Next to, of course, infrastructure. So speaking of infrastructure, what scale are we talking about here? Like in terms of services, availability zones, et cetera. So in terms of services, we have currently about 3,000 smaller services. It's very hard to count, actually. There's probably more than that, enabling 50 different publicly offered services right now. So this is something we offer on a day-to-day basis. And we're currently actually servicing everything in 3 major regions and dividing currently 6 smaller availability zones. It looks something like this. So we have 2 availability zones in the US, 2 in Europe, and 2 in Japan right now. But this is set to expand quite rapidly over the next few months and years. So with that out of the way as well, we have this global self-service cloud that we want to offer. It's sort of a buffet. You come in and you can actually you can pick what you want and pick what you use. So why did we even come to this solution? So basically 3 years ago, we needed a way to give engineers a more of an easy way to interact with the infrastructure through a self-service portal, or at least something self-serviceable. So everything was done through support and going to different teams, cutting a ticket here and there, needed to be more easily accessible. So because of all these pieces of infrastructure being managed by separate teams, you had to know which team to talk to, because yeah, this guy's taking care of that, this guy's taking care of this. It's not the most ideal situation. So we wanted to have this private cloud solution, so we can actually get rid of that. You just go into one place, everything's there that you need, and everything's listed, who to talk to, how to access services. Oh, sorry, went back. So, but it's not just that. You can imagine, like, we can build a private cloud and just offer some infrastructure. Everyone does that in a way, right? But we actually want to leverage the power that Rakuten has, which is the ecosystem services, things you have to integrate with on a day-to-day basis, payment solutions, ID solutions, etc. So it's not just about your container running somewhere. It's about you being able to use the ecosystem services where we can actually bring more value as a company. So basically, we adopted a sort of a hub and spoke model. Basically, the hub is around the data, standards, and specific interfaces, and the spokes being the services offered on this specific hub. And it basically was something like this. So this is something I drew when I was actually thinking, how can we actually solve this? And this is actually the most pretty one I've drawn so far. That's why I'm okay to show it to you guys. But it's basically, the thought is the users at the bottom, there's a user portal, and through different connections and different interfaces, they can, for example, on the left side, interface with the specific services. You can think of your container service, your storage service, but there's all these other parts in place as well. We need an IAM solution for LDAP integration, Okta, or get the actual roles to be set per service. What kind of access do you have? What kind of inventory is there, et cetera, et cetera. So we needed to keep track of everything, and everything needed to make sense. Everything needed to click. So this is a slightly prettier version of that. So you can basically go from the bottom all the way up. So your bottom, you start at your networking layer, your backbone, and you go up to the data center layer, provisioning layers of hardware, network, storage. Then first comes your layer of services that you want to offer, like your container solution, virtual machines. On top of that, we enable the ecosystem services like the ID, payment, points. And on top of that, we want to have the self-service portal, which offers the entire stack downwards, so the services on top can offer their services. And then you have your things on the right, your standards like your logs, metrics, alerting, stuff you want to have, right? The tenancy, resources, governance, things we're adding on top of that in terms of value. You create one tenant, one set of user to be able to access all these different parts of the infrastructure. And last but not least, often forgotten, I guess, quality and security. It's super important to have a good quality system, but also have all the security in place, because especially if you want to grow quickly, security definitely does not need to be forgotten. Oop, here we go. And just to give a bit of a view, like what is this actually hub and this the integrations built out of? These are just a couple of technologies we use. We use so much more. Some of the two other speakers will actually give you a little bit more insight, but we use a various amount of technology to actually integrate services with one another. And we try to keep up to date as much as possible. All right, so many integrations. How do we actually give that structure? So you go from the bottom up, right? So we have the platform API. You can think of your container platform, a Kubernetes, for example. Through the interfaces, you have your tenancy, your inventory, your authentication, authorization, your usage data, budgeting. It's boring, but it's needed, and auditing as well, which then links it up to what we call the service, the OneCloud service or the Rakuten private cloud service, which enables then the ecosystem services and client services. So this is what I want to quickly show as well, maybe a little bit more interesting for people who are actually interested in the technical side of things. Basically, this is how we give authentication authorization. We have the personas on the left, who is integrating, who is actually using these services, and you go from the bottom all the way up. Well, you have your LDAP, or for example, our Rakuten identity provider, which through the middle authentication, so that the OIDC Connect tokens gives you access to either the data or gives you access to the services. So this is basically the core of giving people access to the right parts of the system. And maybe in the Q&A, if someone has some questions, I can answer some. This is also a very important part we set up. So we have some specific levels of integration. So you start at the bottom, you work your way up. You have the service registry, which is basically sort of an announcement board or a way to actually see, hey, this service is offered in our company. And here you can find the guy to talk to start using it, but it's not integrated in the specific cloud. You start to move up the chain. So you have the non-native integration, which is helping with budgeting and billing. Then you go to core data, which gives you access to the tenancy, and it gives you access to usage models. Then we have the API integration, which actually makes sure you can use the authentication authorization to offer your service in a standardized way. And last but not least, the UI. So we have the UI on the self-service portal, where then users can directly interface with your service without needing to understand the API or without needing to really know where to go and who to interact with. So it's a bit high level, but what kind of challenges do we have from this point forward? So we're still growing. We're adding more services, more infrastructure and more ecosystem services. How can we keep the level of detail on the UI, for example, or in the integrations, while still adding many, many, many new products on a regular basis? We need to be able to keep scaling quicker. How can we keep one step ahead of what our customers want? Our customers being, of course, internal to our own company, but still, it's treated as if they're external customers. They want something from us. How can we think of that before they come to us or repeatedly come to us with the same question, right? And would like to stay ahead or at least keep up with the latest trends in the development community. We don't want to end up with a bunch of legacy. We want to have a platform that's modern, reusable, and hopefully as long as possible, bleeding edge. So, oh, sorry, I repeated that specific slide. Sorry about that. That is my complete presentation. It was a bit high level, but I only had 10 minutes. Sorry. If you have any questions, please feel free to ask, and I'll do my best to answer them at the end of this gathering. Thank you very much.
Okay, thank you very much, Mitch. Next, we will deep dive into our technologies more. If you have any questions, please input your comment in Slido that I posted the link in the Zoom chat. Next presenter is Harry, software engineer, application platform group. His session is uncrowding container challenges. Please start.
Yes. Hello, I'm Harry. I work on the container platforms in Rakuten. And in this talk, I will mostly talk about the challenges we faced in our private cloud, which usually you don't face when you're using a public cloud or you're using it as a service or container as a service. So to give you a little background, for any cloud, you need like three main pillars. First one is network, the second is storage, and the third one is a compute platform. And in case of compute, we have two options in our private cloud. The first one is bare metal as a service, and the second one is container as a service built on top of this. And in this talk, I won't go into why we chose Kubernetes as a solution or any other open source technologies as a solution, you can find plenty of information on the internet for it. I would just talk what exactly we did in our private cloud. So to create a container as a service, you can have two extreme opinions. The first one is the PaaS or a Heroku-like service, where developers just give you the source code and everything is automatically done for them, and they don't have to care a single thing about the infrastructure. And on the other extreme end is like a managed Kubernetes offering, where you give them the cluster and they are free to choose whatever solution they want to do on top of this. And in this case, the developer has more freedom, but they also have more responsibilities. And typically, they would need a DevOps and SRE dedicated to manage the Kubernetes cluster per single team. So somewhere between these two extreme solutions lies the correct middle solution. So in public AWS, you will see Fargate, and Google has Cloud Run for this, where they don't expose the scheduler. You just give them the Docker containers and they run this for you. In case of CAS, we chose to expose some of the Kubernetes APIs to our developers, but we don't give them full access to the cluster. So we manage the master nodes and the worker nodes for them, and then we add additions on top of it to make life easier for them. And we have one shared cluster per region, so it's like divided using namespaces across multiple tenants. And then we also provide default networking, CI/CD, service mesh, security, GPU workloads, cron jobs, etc. on top of this. Now, starting with the challenges that we face, the first one is the communication cost. Like I said in these previous slides, if you, in a traditional manner, like if you provided them with a cluster on their own and the developers were supposed to start using the cluster directly, then they would typically have a DevOps and SRE inside their team, and then there would be a really long communication gap happening between them. They would typically talk to them via Jira or Slack and make those informal requests to these guys, and then they would do these operations. And the second cost that adds up is the XY problem. So usually when someone asks someone to implement it, they think they know the solution and then they ask them to implement it. But usually that is not the case. One example would be our users started asking us to add option to um, add certificates on the gateway, that they could call an API and the certificate would be loaded on the gateway. But in reality, what they wanted was to secure their traffic. They wanted HTTPS everywhere. So if we provided them an automatic mutual TLS solution out of Fox, they would really not need that API to insert certificates on the gateway. So this is what the XY problem is. And the third one is validation and policy injection, which is usually done manually after the fact, or usually there is someone who keeps scanning these servers or keeps scanning the status of the servers to decide whether what was done properly or not. So the solution to this problem is to create an internal developer platform and have an API contract with their users. You don't communicate over Jira, you don't communicate over Slack about all the features that you have. The users will typically just call the API or do it via the UI, and then they go through the documentation that you have provided in the written form, then and they would implement whatever they wanted. And in this case, you can easily explicitly define what features you provide and also the features that you don't provide to them. So this also makes it easy to propagate your own culture, own technical culture inside the platform. And it also lowers the reinvention of the wheel that keeps happening across a large organization. And one specific implementation detail of this is Jenga. Jenga is a validation or admission control webhook. It's a design in Kubernetes where all the requests that you receive can be validated in an external entity. So all the different kind of requests that we get, we try to mutate them, add our default values to it, or try to reject those requests if they don't qualify correctly. Like I said, we had HTTPS everywhere in our cluster. So users were not allowed to create HTTPS inside a cluster. So if they only define HTTP, it will automatically convert it to HTTPS. So this is one of the features. And the second biggest challenge is the day two ops. So first, let me explain what this term day two ops is. So in ops, there's the first thing that you do is day one ops. Day one ops is designing the architecture and creating this, designing how much SLA you want and what will be the scale of this. And then on the day one ops, you actually implement that design. You go from a blank slate and then you reach the end destination, which would be like 10 nodes with 3 masters or whatever you wanted. And then comes the real challenge. The day two ops is maintenance of the infrastructure that you already created. This would include upgrades, improvements, measuring the metrics, scaling it up, scaling it down. So usually the day two ops are not very straightforward. Day one ops usually goes from point A to point B and it's like a straight line. But in day two ops, it could be bug fix, could be a simple reload, or it could be patching a file, config file somewhere and trying to migrate it from one place to another. So in traditional way, which is the infrastructure as code way, you would have script X for an action A or script Y for an action B. And then you would run these scripts in tandem or in sequence one after the other. And then you would create a script for every single action that you want to create. But in Kubernetes, they introduce this infrastructure as a data model where you would store the status of the infra in a database somewhere. And then there is a control loop that would reconcile the status from the database and the infrastructure. And on the other end, the control loop, either the same control loop or a different control loop, would try to bring your infrastructure to that state that you wanted. So a simple example in Kubernetes world is the pods. So if you have 5 pods, one of them starts failing, then the control loop will inform this to the data store that one of them is failing. And then another control loop would listen to this and say, okay, let me provision another one, then remove the unhealthy one from the load balancer and then add the another healthy one. And in case of CAS, we wrote a lot of operators for everything from provisioning to our network to creating new users and giving them proper roles. Everything is done through operators. And one such example of this is the Cloud Control Manager. So in case of load balancers, you have a bunch of backends that you would send your traffic to. So typically someone would add whenever you scale out, someone would add more backends to this load balancer, and if you scale in, someone would remove all of these things. So there are many such operations to be done on the load balancer, but if you have a cloud control manager, it would automatically keep a sync of the number of nodes that you are serving in the Kubernetes API, and then it would listen to these events and then automatically add or remove these nodes every single time there is a change. So you don't need to keep doing these operations again and again, and everything is automatically handled for you. And the third challenge is the container networks. So Kubernetes has its own network, and the host network is different from the Kubernetes network. So it does not work with the other private cloud networks that you have. And pods are ephemeral, meaning they come in and go out very frequently. A bare metal or a VM would stay in its lifetime for much longer, around like a week, month, or maybe even years. But pods are usually thought of living as only 1 week or even less than that. So there are a lot of IPs that will be created and destroyed, and there will be a lot of hops also going from one load balancer to the other, and the network becomes difficult to use. So to solve these networking challenges, we follow this mantra of providing good defaults and then let users configure something if they want to configure. So we have something called as the shared gateway and a dedicated gateway. So users, those who don't want to configure a lot of things, they will just use the shared one and then they get an automatic URL assigned to them, and it works everything out of the box without any configuration. But if they want to expose something like Redis or a non-HTTP thing outside their cluster, then they would go for a dedicated gateway, and then they could also define custom domains that they want, and they also get uh, really high performance if they are not happy with the shared one. And then the other problem that we face is the problem of using old school load balancer in a container world. So on the left hand side, if you see this diagram, typically a load balancer would just round robin its traffic across all the Kubernetes nodes, and then Kubernetes would manage the traffic inside the cluster, and then do again a round robin on these pods. So the load is not actually evenly balanced if you send high amount of traffic. So what you really want is a load balancer that understands container IPs, and then it can directly send it to the correct node. So we implemented this container native load balancer using HLproxy and Calico in our cluster. And now it is going from load balancer to the pod is just one hop instead of the two hops that we're having before. And to sum up the future challenges that we have, so our private cloud is still a work in progress, and we are improving quite fast. And the biggest challenge that we want to tackle in the next 6 to 12 months is the multi-cluster networks and deployments. So we don't want our users to even think about multiple regions. Once they deploy a pod somewhere, we want it to be automatically replicated and fail over across multiple regions. And IPv4 is not enough at the scale that we are running. So we either need IPv6 or VPCs to isolate these networks, and also CPU pinning. And we also want to consolidate our network to get rid of all the legacy load balancers and just use a single data proxy everywhere. Okay, that's it. Thank you for listening.
Thank you very much. Thank you, Hari. Okay, let's move on to the last talk by Daniel. Daniel is manager, data product management office. He will talk about Kafka and Hadoop in Rakuten. Please go ahead.
Okay, thank you, Ayana. Hello, this is Lee from the data storage and the processing section in Rakuten. You can call me Daniel. It's a great pleasure to be here today. The topic from me is the Kafka Elasticsearch and Hadoop platform service in Rakuten, and I will share our scale of service and what the problem was we faced and how to resolve. Okay, so let me start from the brief introduction of platform for somebody who new on this subject. So Kafka, so it is an open source distributed event streaming platform, as you may know. So composed by brokers, which is providing distributed persistent storage of PubSub, producer to send the data to brokers, consumer to read the data from the broker. Comparing with other message queues, Kafka is a PubSub system plus distributing load and repositioning the point to read data. And the many precise implementation on controlling methods are delegated to the producer or consumer side. Instead of that, Kafka is providing high performance, throughput, and scalability. So the best match for service which needs a high performance data pipeline, streaming analytics, data integration, and the mission critical application. Elasticsearch is a distributed RESTful search and analytics engine. The most popular use case is the near real-time indexing and search. So very good combination with Kafka actually, when visualizing and exploring the data from Kafka as a streaming. So it has a few types of nodes, as you may know, master data, coordinating, transform, and so on. Hadoop, not to mention, it is the de facto in the open source data lake and warehousing domain. So providing the reliable, distributed, and scalable persistent storage, we call it HDFS. And you can do many distributed processing of large data set on HDFS using MapReduce, Hive, Spark, and other ecosystem on top of a YARN resource and a job management framework. So general architecture, we can consider using these kind of solutions when you select a solution, in case of a big data platform, basically the distributed solution is very important to split the load on the service. Of course, it is in my opinion. So the most important features is distribution. So we can prepare the data streaming implementation on top of Kafka, data lake warehousing using Hadoop, and the delivery buyer Elasticsearch in Kibana. Of course, I'm not talking about this is the only solution. There are many solutions in the world. So the most important things is selecting proper solution for your use case and environment. So from now on, let me share our Kafka Elasticsearch Hadoop platform service. So Kafka service in Rakuten, we have been providing the Kafka service since 2015. Started using the Kafka 0.8 with the plain text protocol. At the beginning, it was enough to address the needs on the stable and the robust data pipeline. But as time goes on, the requirements on security features were requested. So now we are mainly providing 0.11, 2.4 with the SAS plain text and the SAS SSL. This dashboard is showing the data load which we handled during the last Rakuten Supercell at March 2021. We successfully handled in and out traffic 10 gigabytes per sec and 1.5 million messages per sec. It is not including the replica. Using the 62 Kafka cluster with a 7K core and a 20 terabyte memory. The scale and the size of the cluster have been increasing continuously. The mirroring service, we are providing over the region and the available zone, as shared by the Mitch. We are using mainly NiFi and the Mirror Maker. Now we are verifying the active-active mirroring using the Kafka Connect and the Mirror Maker too, of course. This is dashboard from the Elasticsearch. We also are providing this service since 2015 with Kafka together. Started with the 2.x and now mainly the 5.x and 7.x. We have experience on the scalable cluster which handled 1 terabyte an hour and 100,000 documents per sec with 1 month retention in one cluster. Now we are providing the 47 Elasticsearch cluster with 6K cores and 7 terabyte memory totally. Basically, we are providing free version of Elasticsearch with basic license and the plugin. But to support the user who need advanced security features, we also are providing commercial license Elasticsearch cluster. Hadoop. We providing Hadoop for a long time at the beginning of a Hadoop history. Now we are using mainly HTTP2 hotworks distribution platform and HTTP3 as a big box strategy on each region. We are supporting very aggressive multi-tenants who are using the Hadoop as a data lake and analysis, backup and archiving, comparing with the other normal use case. All of CPU intensive, memory intensive, disk intensive use case are running on the cluster at the same time. So totally, we are providing 72K vCore, 442 terabyte memory for job, and 130 petabyte for HDFS are providing to users. This is memory usage metrics for the biggest 2 clusters in Japan region. Graph on the bottom are showing how many tenants are using at the same time. So different color is a different tenant, basically. Our strategy is very unique. We make all resources available to all tenants if there are idle resources at the time. And the support user complete their job as fast as possible using available resources. But it doesn't mean that we do not prioritize between jobs when resources are fully utilized. We are controlling those kind of resources using the fair scheduler and the preemption between users. Also, we are using the QoS features on NameNode. Now, from here, I would like to share challenge and the solution what we used. I'm not going to touch precise engineering detail, but the solution we used instead of that. Let's start from Kafka. So for data mirroring, you might have to consider high latency between regions and the pros and cons of a mirror maker location. Increasing parallelism of consumer and producer are the good strategy by considering the mirror maker location and the increasing number of partitions. So you might be able to face the cluster instability doing high load or general administration like rebalancing recovery after returning the server to the cluster due to the hardware failure and so on. To address that issue, we are selecting the scale-up strategy, not scale-up, to reduce the size of data on broker and increasing the distribution. And JTK, as you may know, JTK has a specification which cannot handle more than one Kerberos realms or service name in one process. Other middleware or programming language has a similar limitation when you use the Kafka. So you have to design very carefully your Kafka KDC realms, considering the strategies of your data mirroring and the utilization. So we are using one global KDC realm and using NiFi to overcome the those limitation for data mirroring. So NiFi is also a good solution to overcome the mirroring between the heterogeneous data source and destination of Kafka. And the other memory issue on broker or zookeeper, it is usually due to users' usage of Kafka. So guiding user to the best practice is very important based on the use case. And authorization on Jet node in zookeeper can be good strategy to avoid this kind of situation. Elasticsearch, basically this kind of issue from the use case which we need to handle unfixed documents structures and extremely high index and query load at near real time. So balancing load on each data node, it was very important to implement well distributing and controlling the index and shard, not just lean to the default allocation logic from the Elasticsearch. So this is architecture we have selected in the past to handle 1 terabyte on hours and 100K document per sec with 1 month retention on the cluster. So basically, we are allocating dedicated coordinating node as indexing and the query nodes, and the data node and the master node the dedicated way also mandatory. And in addition to that, in indexing node, a few of grouped index node has been allocated for particular high load index also. Data node also has been grouped and subgrouped according to the attributes, index load, and hot and cold strategy. Okay. And all indexing load going to the dedicated indexing node, and it has been routed to each hot data node grouped based on the load of document per sec controlled by template. And all the index which would not be updated anymore in hot node move to cold nodes and change to read only periodically. When we need more retention on the particular index, we just add more node on only target group of data node. So query from Kibana or REST API are allocated to the dedicated query node also, separating with the indexing node. So depending on the query condition, particularly the period of time is one of the biggest factors which giving high load on the data node and the client node. We can distribute the load on the data node by grouping based on the hot and cold on load on the index. And Hadoop. This issue might be very general to other Hadoop users who are running Hadoop cluster in each company. But in case of us, it was very particularly more extreme and harder to handle due to highly aggressively multi-tenant and a mixed use case in our mixed use case. So resolving issue, we have introduced, for instance, a preemption and a name node QoS to mitigate the influence on the job pending and the delay, keeping idle system resource available to all of tenants. In addition to that, we introduced a node labeling for particular users who want to have their own 100% dedicated resource for their critical job without any interfering by other tenants. And the name node federation to scale out the name services to address totally hundreds of millions of files on the HDFS. I think our use case is very, very big from the point of this kind of numbers. More than one zookeeper to distributed load of transaction from name node, resource manager, and so on. It was also important to avoid fourth zookeeper failure, failure controller, and so on. So, future. Now we are moving to the self-service style on top of our private cloud introduced by the Mitch. And we are moving to introduce our self-service based on our rich experience. And also looking for the containerization of this kind of solution to provide more flexibly and efficient system resource utilization. And of course, we are looking at another next generation solution instead of Kafka and Elasticsearch, of course. And as you may know, these days, Hortonworks changed their subscription policy, and we are considering return to the original Apache Hadoop solution, move from Ambari to Chef or Ansible. Actually, we continue to use Chef from the beginning, and we are planning to make our own distribution version of Hadoop using Apache Hadoop source code and so on. That's all from me. And if you have any question, please feel free to ask a question to us. And thank you.
Thank you very much. Yeah, if you haven't, please input your comment and questions in Slido. Next, we will start a kind of panel discussion based on the questions from you. And that's why I'd like you to not to hesitate to input your questions. You can also like questions by others, and we will take it from the most popular one. Okay, and before starting Q&A, we have one important announcement. Let me share my screen. Dun, dun, dun. Yeah, now we are hiring. Here you can find Rakuten services, culture, and how you can work with us. And the second link shows the positions that are available, especially our department. Sorry, this is the second link. If you input CPD here, CPD stands for Cloud Platform Department, you can find the positions that are available now. And if you click the position that you are interested, you can see more detail like this. You can see the job description in detail, and you can also apply from here. Okay, and you can find the similar jobs, something like that. Yeah, we are looking forward to working with you. Please try to apply if you are interested. Okay, then let's start the Q&A discussion. I hope we can see a lot of questions here. Yeah. Okay. I will read it from the top. Let me delete the first one. Okay. The first one is just about the presentation material. I think we can share it. How do you usually do? I think maybe we can post it in the Compass here. Yeah, here. We will do it by tomorrow. Let's move on to the next question. Regarding Kafka streaming and Spark streaming, what are the major differences and how should we choose one of them in the actual project?
Actually, it's not related with the content today, but basically the Spark streaming is a micro batch, but Kafka stream is not a micro batch. Actually, the streaming framework. So if you really want to implement a near real time, you'd better using Kafka streaming. And another difference is Kafka streaming is depending on the your implementation. It's gonna create some the arbitrary topics on Kafka cluster. So it's kindly linked to the Kafka clusters itself. And in case of Spark streaming, you can run the Spark streaming on any containerization system. But from time to time, you might have a dependency on the HDFS or the other reliable distributed storage for keeping important checkpoint information and so on. So the most important thing is which one is better, nearly pure streaming framework or micro batching. Yeah, I hope this answer is good for you.
Okay, thank you very much. Any additional comment? Okay. Okay, move on to the next one. What is the intention of having private cloud rather than using public cloud? Performance, cost, freedom, anything else?
I will take that. If that's okay. So it's basically everything that you listed and more. So of course, cost always plays a role when you make a choice between a public cloud and a private cloud solution. Private cloud solutions are not free. You have to use engineers to build them as well. So it's not that it's like it's a better option right off the bat, but there's a lot of benefits we have with using our private cloud solution. We can actually build that to meet our exact needs, like the ecosystem solution, for example. We can actually directly integrate our platform with the smaller services that we're trying to offer that we cannot offer to the general public, right? For example, Rakuten ID is not something that we can just offer to everyone, but it's something we want to use internally. So we can better integrate that with the systems that we have to make it more easily usable. So cost is definitely a part, but better integration with the Rakuten ecosystem and the service that we're trying to offer is also extremely important. And anything that we do, from like an API that we design, an interface standard or a naming standard, a namespace convention, anything you can think of can all be catered to our exact needs. And we do not have to adapt to a specific standard that's set by a public cloud provider. But those are the biggest benefits. Of course, there are some drawbacks, of course. We have to rely on our own hardware and we have to purchase that hardware on time. With public cloud, it might be easier to scale based on our needs, but the benefits for us just weigh much heavier compared to some of the drawbacks of having your own private solution.
Okay, thank you very much. Next one is there any backup taken for each indices? How do you handle in case of cluster failure?
I think this is related with Elasticsearch. So basically, our strategy is do not take any backup. I mean, run the snapshot, because our use case is data exploration and so on. So not storing those kind of important information. And using the system resource for snapshot is kind of expensive in the middle of a high load of a cluster to handle the index and querying and so on. But so we do not take any backup. But instead of that, we always prepare the how we can recover as soon as possible in the middle of a stream pipeline to indexing the data. So before that, I mean, before indexing, we always prepare the Kafka cluster. And another one is more longer term data. We use the Hadoop to back up the data to HDFS, not from Elasticsearch to HDFS, but from Kafka to Hadoop. So by those kind of response, we are not using the backup on the Elasticsearch. Thank you.
Thank you. Next one is there any queuing mechanism to prevent platform resource exhaustion? Also, could you please show again the list of custom operators in your cluster?
I think this one is for Kubernetes. So since we are running on-prem on our private cloud, and as Mitch explained, we need to buy our own hardware. We actually don't run into this problem of resource exhaustion because we already know how many resources we will need, and our cluster is scaled according to that. So if you're allowed to deploy, it will be scheduled. So if you're not allowed to deploy, which means we don't have enough hardware for running those things. And the list of custom operators, I think we will upload these slides. You can look at that.
If you
Yes.
don't mind me adding a bit for the resource exhaustion, like
Mhm.
people might be asking, how do you guys know how much hardware you need? This, of course, we do forecasting as well, which is also a benefit of being a private cloud. But we also buy extra buffer hardware to make sure, you never know what happens. See, last year, for example, COVID was very good for parts of our company in terms of growth, but that's not something you can plan for. But we do purchase specific buffers to be able to handle those sudden increases of traffic or compute requirements. So it's of course not perfect, but we try our best to forecast our needs and to add an additional buffer on top of that to make sure we do not run into those issues.
Thank you. Okay, next one is for data warehouse, Hadoop or HBase or some DBLs. What are the most use cases for these two major DB?
Oh, kind of a difficult question. So okay, so basically HBase is on top of HBase is on top of HDFS and the Hadoop, the other ecosystem applications and so on, as you may know. So it is not a different one. So the most use case between using the pure Hadoop or HBase is how to query the data from the Hadoop cluster and whether the user needs to update the data without any dependency on Hadoop characteristic. Basically, the Hadoop doesn't allow the updated effect, purely thinking. It's just adding, deleting, or something like that. But on top of that, the HBase is providing updated way, like a KVS style, key value store style. And it is completely transparent from the point of user, but under the ground, there are many things running on. So somebody who want to handle the more precise enrichment or cleaning and so on, they are just using the pure Hadoop and directly the running the Spark or MapReduce or Hive and so on. And but somebody who want to deliver already manipulated data on Hadoop, usually they are using HBase actually. And more scalable, I mean, some users who are using, who want to use a key value store, but a more high scale level, which cannot be handled like a Cassandra or the other KVS store, then somebody using the HBase actually. Yeah, I hope this answer is good for Eric, maybe.
Okay, thank you.
Thank you very much.
Oh,
Thank you,
next
Ali.
generation of a Kafka cluster.
Yes.
Okay.
Would you please elaborate in the
Okay.
next generation of Kafka cluster that you are developing?
Oh, today's the question level is very high. Okay. So as you may know, I think engineers who are using the Kafka for a long time, they're gonna usually face the issue from the point of a scale up. So basically, the Kafka is using local disk. Of course, we can use the network storage just mounting on the servers, but in case of the performance is not so good. So usually, we select the local disk on the server. It means that whenever we scale out the Kafka cluster, we have to add a node and we have to increase the partition on particular topic. So from the point of that, scalability is kindly, how can I say, dependency on the server. But so, and the number of partition is something like a bottleneck in case of Kafka. I heard that from the engineers of Kafka in the Kafka conference, looks like 1,000 or 2,000 is the preferable the indicator when we increase the number of partition per node. But anyway, so those kind of things can be very critical bottleneck when we run the Kafka cluster. And a little bit more flexible operation on topics and more separation. I mean, in case of Kafka, we have to use the CPU and the memory and the disk at the same time to storing the data or reading the data and processing the data. So for instance, I don't know these days it is popular or not, but Apache Parser or some other solution is looking at separating those kind of accepting part and the processing part and the storage part, and make each two layer more flexibly scalable and flexible, and decoupling the system. So those kind of, from the point of view, we are looking at the next generation of solution, not the new version of Kafka. Of course, we are continuing to looking at the new feature of Kafka by the upgrading and so on. But fundamentally, completely different solution we are looking at as a next generation. I hope this can be a good answer again.
Well, thank you. Okay, next one is interesting. Since you are hiring, can you describe a regular day schedule for a day in CPD? Okay, maybe it depends on the position and depends on team. But sorry, before answering this question, it's time to have a closing. It's 8:30. So we will keep talking based on their questions. But before that, let me do some announcement now. First, I think we would like you to create a corporate survey. Neo, could you send the link? Yeah, thank you very much.
Yeah, just
Yeah.
quote. Yeah, please
Okay.
take the survey to help us make the event better. Yeah.
Thank
Check
you.
out the link I sent.
Yeah.
Thanks.
Before leaving, please cooperate it. Thank you. And as closing, first, we would like to say thank you to everyone who joined our talk. And we are very happy to see a lot of people interested in our talks. If you are interested in working with us, please visit the link I shared. You can also contact me directly if you have any question. I will post my my email address, and you can contact me by Twitter if you have account as well. And do you have any other announcements from Neo?
Oh, no. Thanks for the great talk. And thank you for moderating the event. So I guess after this, we will continue to all of those Q&A answer, right? And
yes.
maybe have a network session so that if everyone wants to talk with speakers, we can network a little bit afterward, right?
Yeah, thank you very much.
Okay,
this is the end of closing, but as he said, we will start networking and keep answering your questions for another 30 minutes until 9 p.m. If you have time, please stay, and you can also join our discussion casually if you want. In case that you have another appointment, you can leave now, but thank you again for joining today. Okay, then let's move to the after talk, and let's take the question. Okay. First, let's take this one. Could you please describe a regular day schedule for a day? Not of you, maybe a team member or usual engineers. Maybe Mitch.
Sure. So it, like I already mentioned, it really depends on where you are in CPD. So under myself, for example, it's mostly developers. So I can at least explain what a developer's day looks like, basically. So for this team, I basically follow Scrum. So the day usually starts with a stand-up. We have a quick discussion with each other, 10 minutes, like, hey, how were things yesterday? Do you have any impediments, anything we need help with? And just a quick catch-up with one another. Then basically, if you look at the developers themselves, the engineers, we go into our Jira boards. We're going to take a look, what are we going to work on today? And we're going to start coding. We have a certain amount of time per day that is set for pull request reviews. We help each other. We do pair programming. It really depends on the day, to be honest. It's very flexible, up to the engineers themselves. And we usually end the day with a quick note to themselves, like, hey, this is what I've achieved today, and tomorrow I'm going to do it again. So that is basically a developer. It's a little bit high level, but basically we don't do a whole lot of overtime. As much as possible, I'd like to keep it flexible. People have their own way of doing things, and we only care about work is done. We do not care so much about like the exact timing of when someone is working. So I would say the working culture is quite flexible. Let's see what else. You may or may not know Rakuten has adopted English as its primary language. So most of the communication is done in English, but we of course also have Japanese members, and Japanese language is also freely spoken if of course needed. Let's see, anything else that is interesting. So for non-developers, let's say look, project managers or any sort of managers doing discussions, etc. It's a day of talking to people and creating user stories or tasks or conference pages. It's just a day of gathering information and working together. I'm not sure if that really explains it. If you have anything very specific you'd like to ask us, like how is this or how is that, that might help us being able to pinpoint answer your question a bit better. But that's it, at least from my side. Maybe Daniel has something he'd like to add.
I think it's very similar with you. Just completely depending on the where you are working for. I mean, the per groups or per teams or your role and responsibility. So basically, all of developer in CPD, I think similar as what Michelle described. I think so. Yeah.
Yeah. Okay, let's go back to the technical question. Have you ever encountered any problem with scaling Kubernetes cluster when tenant increases, since there is only one shared cluster in each of the availability zone?
So right now, we haven't reached the scale where Kubernetes scale will be a problem for us, but we expect it to reach soon. So we are preparing for dedicated cluster approach also. So if we have really big clients, so we will give them dedicated clusters. But right now the shared cluster is good enough for our scale.
Okay, thank you very much. Any additional comment? Nothing? Okay, next one is regarding private cloud. I think one of the biggest challenges is to scale hardware since it takes time. How do you plan to buy new hardware to meet your need? We will take it.
Okay, that's an interesting question. How do you plan to buy new hardware to meet your needs? So part of it comes from forecasting, right? And of course, looking at private cloud, it's not that we start from scratch. Like all of our services are already running on something either in our own data centers, or we also use public cloud. So we know what we're using right now, and we can anticipate the usage requirements of our tenants, so to say, or our users. So sure, there's only so much we can do. Like I also mentioned, we do buffer, we do add more, we do purchase more than we actually need. You could buy, for example, a server with the CPU that just needs your requirements, or you could buy something that really comfortably meets your requirements. And we'd rather lean towards being comfortable. So we do buy machines that are a little bit over capacity, over powerful. Maybe that's better. So we do, when we purchase things, we do make sure that we buy more than we need so that we can at least handle if there's any spike or anything that we require. And other than that, there's always ways for us to move things around, things that maybe don't have to run right now. We could scale those back in favor of services that do need more capacity should we have actual resource limitations. So that's basically what we do. There's always some limitations. There's always the potential of us having to use a bit more public cloud, but as much as possible, we try to buy things more than we actually need in advance.
Okay. Thank you very much. Next question is, any experience or suggestion about testing and gradually upgrading software components in your cloud platform can be shared? Like etcd for Kubernetes is so notorious.
Yes, we spend a lot of time testing our upgrades and components. Actually, I've written an open source project called Shibuya, which is available on Rakuten's GitHub. So Shibuya is just for load testing our clusters. So we do so every time there's an upgrade, the load test scheduler will kick in and will start sending load to test whether these upgrades are happening or not. And then we also have a functional test written in Go that would keep testing whether all the APIs of Kubernetes are working properly or not. And then we also have a bunch of different lab clusters and alpha and beta clusters. So the same process that you follow for any regular software, we follow it same for our infrastructure software also. So it slowly rolls out from alpha to beta to dev clusters to production clusters. So it follows the entire software lifecycle.
Okay, thank you very much. Next is about management. How a manager or the upper managers evaluate the platform team's performance? SRO may be a standard, but how about like usability to tenant?
Very interesting. Basically, from me, it's the usability or the customer satisfactions is 100% up to users, right? So we don't know how the customer gonna respond on our service, like user interface and so on. So basically, we kind of lean to the users' feedback, and our account management team is continue to contact with the customer and gathering the information or some feedback and needs and so on. So based on that, we are talking with service providers how we can improve those kind of things. So on top, but in the middle of those kind of actions, we are evaluating our platform team's performance. But to be honest, the indicator, I mean the KPI for team's performance is of each teams. So for now, there are no standard, but yeah, so very interesting topic. Maybe I can bring this to our account management team. Yeah.
Maybe something I can add, because I think usability to the tenant is a very important thing.
Yeah.
Right. So what we're basically doing is we're treating this as if we're offering this to the public, right? And if you offer something to the public, you want to get your feedback from your customers to improve things. So there are many frameworks to do that. One of them is the NPS framework, for example. You just simply ask, how do you feel about this? And you get a number, and that is basically a sort of an abstract way to see how you're doing over time. But we spend a lot of time with our customers, so our tenants, either privately, directly, so in one-on-ones, we have interviews with them, and we actually focus on a product. You could be Hadoop, it could be something completely different, like our Kubernetes platform, and we just sit with them. This is the UI that we've built. This is the platform that they're using. How do you feel about it? Any issues you have? Can we watch how you interact with these systems? And do we maybe find any issues? Or maybe you cannot find where something is and we need to fix that. So for us, we evaluate using NPS, but we are always talking to our customers directly or through surveys to figure out how can we better this platform, how can we improve it, because it will never be perfect. It will never be the best we think it can be, and we will always try to keep improving by simply asking the question, how do you feel about it right now? And is it usable? Does it help you in your day-to-day job? If not, then we're doing something wrong. We need to fix it. So that is basically how we try to improve things. And NPS is but one of the scores to try to sort of objectively measure how we are doing. So maybe that answers the questions a little bit.
Thank you very much. Next one is how flexible it can be for platform tenant. For example, if one department or one project needs a Kubernetes extension that the current platform doesn't provide.
I think I explained this in the previous slides where I showed the Heroku style, no customization, and then GKE style, full customization. So we are similar to GKE's autopilot mode that they released a few months ago. So there are some extensions that can be provided, but not all. And our philosophy is not to have pets, but to have cattle, meaning we don't try to solve a problem just for one special snowflake of a case. If a problem is decent enough to be solved, we would solve a general case and provide it to every single tenant. rather than solving it just for one specific tenant. One example of this would be like some people wanted Nginx ingress, but we chose Istio as the service mesh, and we also have integration with our own in-house gateway that was written in Nginx plus Lua. So we provide these two gateways as our option and not the upstream Nginx, because these two are good enough for every, like almost 99% cases.
Okay. Next one is whether any tech developed during developing company private cloud has been contributed back to OSS project, like to Kafka or Kubernetes upstream.
It's quiet. So I can at least share like to these two projects. I'm not so sure, but we are actively looking and contributing more actively, basically in the open source community. So there's a few things we have been building internally to enable our private cloud that we basically could not find any solution for on the open source community, at least something that not fit our needs. So for those specific cases, we're looking on making our solutions open source in the future. And none of us three here have, I think, any information, but I do know in CPD there has been, in Cloud Platform Department, sorry, there's been quite a few contributions back to open source to specific problems we encounter with a library or a framework we've been using that we have helped fix it. If I had known this in advance, I could have prepared something to show you, like these are the commits you can find on GitHub, for example. I don't have that, unfortunately, but that is something that we are trying to improve quite a bit now, is to be more active player on the open source community as the company as a whole, actually, not just our own department. It's something we're trying to improve in the future.
Okay, thank you very much. Next one is a kind of internal question. Is there a Terraform provider for OneCloud, and if no, when it will be available? And I asked my co-worker. He said he is developing it, but we for now we cannot promise by when we will create it. So please wait for a while. You can contact me for more detail internally. Okay, next one is the last one. But you can add more question if you have anything. Anyway, services collaboration in cluster. Do you use node port cluster IP service name? For cluster IP, how do you keep cluster IP static for internal container services?
Yes, so this is actually a problem I'm working on right now. Yes, so we have something called as GSLB. It's like a global software load balancer, and it has its own global domains. So like the multi-cluster future challenge that I talked about. So I'm trying to solve these both at the same time. We are trying to have a global service name, which can be accessed from any region, any cluster, anytime, and it will be local aware. So if you're calling it from Japan, it will go to the pods in the Japan cluster. And if you're calling it from US, it will go to the pods in the US cluster. And if it's running inside the same cluster, then it would directly go to the cluster IP, whatever is the latest one for this. So right now it's a mix of load balancer IPs and like random domains, but soon we will move to these global domains. Yeah.
Hey. Okay, any other question, comment, anything you can input, or you can talk directly? Let's see the questions that we received today. Any topics that you want? Is it difficult to see?
So, excuse me, I have a question.
Okay, come on, go ahead.
Thank you. So, is it okay for me to turn on the video, or this is fine?
Oh, of course, of course.
Awesome. So, I hope I'm audible.
Yes.
Right. Okay. Awesome. So my question is basically, to start off, my background is not from big data or Hadoop or Kafka or anything. To be honest, today was the first time I actually got an understanding of what exactly is Kafka, and maybe I can work on my understanding from now on. But then I had a quick understanding of when you use this phrase, scaling out rather than scaling up. If you could just like help me in understanding this phrase better, I would appreciate that.
Okay.
And how do you guys go about it?
Okay, I think that this is a question to me. So the strategy between the scale out and the scale up strategy, for instance, almost the solution on the big data platform is just cluster, right? So cluster is composed by many nodes. So scale out means we adding more node in one cluster to increase the capacity or processing power and so on. Scale up is we are not adding more node, but adding more CPU or adding more disk, adding more memory physically, and increase the capacity or performance. So both of strategy has a pros and cons. For instance, in case of a scale out strategy, so if we add too many nodes, from the point of administration, it is very hard. So instead of that, we need to make sure about how we can make the administration easy. But pros is we can distribute the data size on each node or load on each node. So for instance, when we have a one node failure, if that one node have too much data to recover or replicate the other node as a failover, if that node has too much data, it means that the recovery or failover time is going to be take so much. So instead of so in case of scale up, it's completely opposite. So but if we keep too many data, it's going to be the problem. And so depending on the solution, you have to decide which one is better. So in case of Kafka, Kafka, the main purpose of Kafka is distributing the node and handle more and more. So, and the Kafka is basically Scala, but under the ground is Java, right? So in case of a Java application, there are some the best practice not to set a high heap size or something like that. And based on the heap size, there is some the preferable size of data which Java application can handle. So considering about the characteristic of a middleware of a cluster, we have to decide it very well which one is better, scale out or scale up. So there is those kind of concept, which one is better. So during the Kafka failover, we faced many some of the issue for failover the data from one node to the other node, cause high in and out traffic, and those traffic cause interfering which have to be done for accepting the data from user or providing data to user, I mean the producer and consumer. So we split it out those kind of data using the scale out strategy to keep the system resource for normal users who have to use Kafka, not under the ground of Kafka cluster. Is that the answer for you?
Thank you so much. So you guys basically add more nodes rather than increasing resources on the same node per se.
Yeah. Exactly. So of course, again, it is up to the middleware and strategy. So instead of that, we prepare the very automated administration tools and so on.
Right. Thank you so much.
Yeah, my pleasure. So, thank you.
One more question I had is, I've been reading a lot about blockchain these days, and I was just wondering if Rakuten or your department, I think it's CPD, right? CPD.
We have blockchain
or
technology
Rakuten
department.
Yeah. So in general, Rakuten as a company, do you guys have any sort of projects which involve blockchain or the use of blockchain as a third party or something like that? I'm just curious. Thank you.
From me, as far as I know, some of our project is using blockchain. And we have a dedicated research department, right?
Yes.
So there are gonna be some department who are investing and researching the blockchain itself. So except for that, I don't have any detailed idea. So maybe if you are interested in that, you can take a look at the JD of Korea. Ayana already shared. There gonna be some JD about that. I think so.
Yes. We have
Right,
a
awesome. Thank you.
cryptocurrency service, Rakuten Wallet, and also we have a blockchain lab in Belfast. But some
And
members,
Ireland, yeah.
yes, but some members are working in Tokyo. So
Awesome.
yes,
Thanks. I'll look into it.
you can input blockchain here. I'm not sure how many positions are available, but please try to check.
No problem. Thank you for letting me know.
Okay. Thank you.
Yeah.
Thank you for your questions.
Awesome.
We have 5 more minutes. Yeah, now you can see the keyword that from the question we got today. And here some question we received today. Do you have any, do you want to add more comments, any additional questions? Maybe the next one is a one or two more questions before finish. Anything else? You can turn on your microphone if you want to talk with speakers. Okay. If not,
So Ayana, sorry to interrupt. I just would like to know what sort of software are you using right now? So I tend to attend meetups frequently, and this is the first time I'm seeing of this format. You know, the way you've actually portrayed the keywords and the questions. Initially, when the session started, I was wondering why wouldn't people just text directly in the meeting itself inside Zoom? But now that we've reached to the end of it, it makes sense why you're using a third-party service. Or is this Rakuten's application or something like that? Is this open source?
it's very popular tool called Slider. Now you can see the screen, and if you go click, I think you can go to the home page. No.
I don't think
Yeah.
this is open
Otherwise,
source.
search Slider. Anyone can use for free.
Ah, awesome. So
Yes.
this is like a third-party company. Okay.
Yeah.
Yes.
Got it.
Thank you. Okay, so shall we wrap up? Any closing comment from speakers and organizers? So, how about you, Danielle? Was it fun?
It was my pleasure to see everybody, and feel free to ask questions to Anna and the other organizer of this meeting. We're going to answer on your question as much as possible. Thank you.
Thank you. How about you, Harry?
Yes, thank you for listening and asking all of these questions. It's good to know that in Japan also there are a lot of Kubernetes users now.
Yeah, thank you very much. Mitch?
So thank you everyone for joining today. I saw the question that some of you would like to see the presentation once more time. Maybe next time we'll prepare those things in advance. But hopefully we answered at least all your questions. And if you have anything you'd like to know, please feel free to let Ayana know, and she'll pass it along.
Yes,
so thank you very much for being here today and listening to us.
Thank you. Yes, thank you very much for inviting us to this meetup. Neo, would you like to close?
Yeah, and thanks for speakers for the great talk. Like I guess we got a lot of knowledge today. So and thank Ayana for moderating this event. Yeah, thank you. So we will keep going online afterwards. So please subscribe to our YouTube channel and also our campus group. So yeah, let's meet next month.
Yeah. Okay. Thank you very much, everyone. Have a nice evening.
Thank you.
Thank you for joining. Thank you.
Thank you.
Thank you.
Have a nice night.